ईयर स्टूडेंट्स, अगर आप इन वीडियो लेक्चर्स का मैक्सिमम यूटिलाइजेशन करना चाहते हो तो आई थिंक आपको ये इंप्रूव सेशन डेफिनेटली फॉलो करना चाहिए और रिलीजियसली फॉलो करना चाहिए। इंप्रूव सेशन क्या है, इसका लिंक डिस्क्रिप्शन बॉक्स में है, तो जाओ उसको चेक करो। इसके अलावा अगर आप व्हाट्सएप ग्रुप ज्वाइन करना चाहते हो, और मुझे लगता है आपको करना भी चाहिए, तो आप क्या करो, हमारे वेबसाइट पे जाकर के अपने कॉन्टैक्ट डिटेल्स दे दो या फिर इस व्हाट्सएप नंबर पे जाकर के अपने कॉन्टैक्ट डिटेल्स दे दो, सो दैट हम आपको उसमें ऐड कर सके। चलो अब पढ़ना शुरू करते हैं।
Hi, in this video we'll be talking about the basics of kinematics. So this is like a quick review guide. So in kinematics we have the basic equation v is equal to like dr by dt, and this is instantaneous velocity, and this a is equal to dv by dt, and this is instantaneous acceleration, and this is instantaneous velocity. And we also have the average forms. V average, the like in interval going from t1 to t2 is going to be delta r by delta t, where delta is the net displacement and this is the total time. Similarly, average acceleration is going to be like change in velocity divided by total time. Okay, if I'm talking about, in this case suppose I'm talking about speed, so this instead of v bar is equal to dr by dt, and this dr is going to basically rate of instead of rate of change of position vector is going to be rate of change of distance traveled. Okay, and the average form is going to be speed average is going to be change in like instead of change in position vector is going to be total distance traveled. Okay, so let's see how these equations like we can use this equation to figure out the kinematic equation. So I'll just write here our basic kinematics equations. So they are v is equal to u plus at, and then we have this s is equal to ut plus half at square, and then we have the scalar equation v square is equal to u square plus 2as. Okay, so let's use first this equation to figure out v is equal to u plus at. As you should be able to see, this is dv is equal to adt. If I'm going to integrate both sides from u to v and this from suppose 0 to t, so this in left hand side integration is going to give me v is equal to u, and this is going to be adt plus at. Okay, so this is basically v minus u. I'm taking u to the right, this is going to be u is equal to u plus at. Similarly, using this equation, what I'm going to get, v dt is equal to dr. If I'm going to integrate both sides, I can write this equation, vector equation, v is equal to u plus at. So this integration becomes u plus at dt integration of dr, and this integration is going to become ut plus half at square, and this is basically change in position vector going from some ri to rf. So this integration is going to be rf minus ri. Okay, now we have this equation v square is equal to u square plus 2s, and this is scalar equation. So for this we are going to use the scalar form. We have this a is equal to dv by dt. What I can do, I'm just going to divide this right hand side by ds, and again I'm going to multiply by ds. So this equation remains same, and this can be written as dv by ds, and this ds by dt is going to be v. So, and this is nothing but your a, so I can write v dv is equal to ads, and then I'll integrate both sides from u to v, and this is again some 0 to s. So this becomes v square minus u square by 2 is equal to as. So finally this becomes v square is equal to u square plus 2as. Just keep in mind this v is equal to u plus at, and this is basically like change in position or the displacement is equal to ut plus half at square. These are vector equations, and this v square is equal to u square plus 2s. This is a scalar equation. Okay, there is one more derivation. This is basically the distance traveled in nth or tth second. So basically a body is starting from point A, and you are asked to find like calculate the distance that body is going to travel, suppose in the 10th second or 5th second. So what I'm going to do, so suppose the body is going to travel from point A, this is a starting point, and this is the interval in which I'm supposed to calculate the distance travel or the displacement. So suppose I'm saying what is the distance traveled in the tth second. It's nothing but the distance traveled in t second up to t second minus the distance traveled in t minus 1 second. So this is a point t minus 1 and this is a point t. So if I want to calculate this distance basically, so I'm just going to take this whole distance and minus this distance traveled. So distance traveled in tth second, distance traveled in tth second is nothing but the distance traveled in t second minus the distance traveled in t minus 1 second. Okay, so suppose the body is having a constant acceleration a, so the distance traveled in t second starting from initial velocity u is going to be ut plus half a t square. So I'm assuming the body is having a forward acceleration and this is the forward initial velocity, so both u and a are in the same direction. That's why we are having a positive sign, otherwise it's going to be a negative sign. So st is going to be ut plus half a t square. Similarly st minus 1 is going to be u t minus 1 plus half a t minus 1 square. Okay, so the distance travel in tth second st minus s t minus 1, and I'm just going to subtract this ut plus half at square minus this whole thing. If I'm going to open it up, it's going to be ut minus u plus half a t square, so 1, so this is minus plus half a and then plus half a into minus 2t. Okay, so this ut and this ut is going to get cancelled, and this half at square and this half at square is going to get cancelled. I'll just open this up, and so opening this value, like solving for it, I'm going to get this minus u, so this is positive u, and this minus a by 2, and this is already negative, so this becomes plus 80. So this is basically u minus a by 2 plus 80, or I can write it as u plus a by 2 2t minus 1. In many books you will see instead of t they are going to write n or the nth second, so I can also write it as u plus a by 2 2n minus 1. Okay, so this is the distance traveled in the nth second. Okay, so and some people also get confused with, since this is distance traveled and here I'm writing u and here I'm writing a by 2 2n minus 1, and this distance traveled is not having the same dimension as u. That's not the case, because here I'm multiplying like by 1. Okay, so in one case this is t minus 1, this 1 is also a second, and so this is not just u, this is multiplied by a constant 1 that is having a dimension of second, so that ut becomes the dimension of s.